In our last lesson, we learned what function notation is, what a function is, and how to write it using function notation. Today, we're going to focus on something called a composition of functions. Let's look at our very first example. So, example number one, find f, and then there's this circle. I'm kind of looking at that. Is that an O? Is that a degree sign? What in the world is that? It's actually a circle. F circle G of 5. What in the world is this circle? You know, this whole unit's about notations and symbols. Well, here's a symbol that may not be familiar to you. So when you see this little circle, it represents what's called a composition. And I do recommend you write these examples down, work them out along with me. And a composition is, to put simply, it's when you put a function, one function, inside a different function. Okay, so when you have this little circle here, this can actually be rewritten as f of g of 5. In essence, we're taking this g of 5, finding out what g of 5 is, and then whatever answer we get, we're going to input that answer into f. So there's a lot of different ways to write this. Different teachers will do it differently. The way I like to do it, I like to use these little kind of like carets below the problem. When I draw this little caret, what that's going to mean is that we're going to input the 5 into G. And in this case, you always want to work kind of from the inside to the outside, or we're, in essence here, working from the right to the left. So start by plugging the 5 into G. Take away this x, replace it with a 5. That would be 9 times 5 plus 4. All right, that comes out to 49. So when I input a 5 into G, I get this output of 49. Now, a lot of times I put a box around this output because that's not my final answer. It's kind of a preliminary answer. But now that I have this output of 49, now I have to take this output 49, and now I'm going to input it into the F. In other words, I'm going to take away this x and replace it with this input of 49. Instead of 3 times x minus 1, I'm going to do 3 times 49 minus 1. Now this would be my final answer, 146. I'd like to give you a little visual to go along with that first example. So our first example, we had to find f circle g of 5. And when you have a composition, in essence what's happening is take this number 5. Imagine that we took this number 5 and we plugged it into a machine called G. And G is this machine that whatever number you plug into it, it multiplies that number by 9 and adds it by 4. Well, if we were to input this 5 into the G machine, of course we would get the number 49 as an output. But then with the composition, imagine that these two machines have been hooked up, maybe via a conveyor belt, and that whatever comes out of this machine G goes directly into the second machine called F. And the second machine, whatever number you input into it, it multiplies it by 3, it subtracts it by 1. We get this final product of 146. That's how a composition works. So as we move to the second problem in this example, I want to know with the composition, if we flip the order, if we change the order of the composition, do we get the same answer? In math, this is called the commutative property. Are compositions of functions commutative? Can you switch the order and get the same answer? Well, let's try this out. And by the way, I'm using the same functions we had here as yesterday. These are just randomly picked, okay? Functions can be named anything. I'm just sticking with these F, G, and H. But let's start by taking the 5, and this time let's input it into the F first. 3 times 5 minus 1. Well, when I do 15 minus 1, I get an output of 14. Of course, with the composition, once I get this output of 14, now I'm going to plug that 14 and input it into G. 9 times 14 plus 4. Now let's see if we get the same answer or a different answer. I'm going to cheat, use my calculator. 9 times 14 plus 4. It does come out differently. It comes out to 130. Compositions of functions are not commutative, meaning if you switch the order, you're very likely to get a different result. The answer to this one, 130. Now, you're going to love me for this check problem. There's no limit to a composition. With compositions of functions, you can keep putting a function inside another function, inside another function, inside another function. You can do this forever and ever if you want to. So here's a check problem. Get your calculator ready. Give this one a try on your own. Go ahead and hit pause. Try this on your own. When you hit unpause, we'll give you the answer. All right, and here is your answer. I'm sure you had to work for it a little bit. Here, real quick, how I broke this down. If you plug 2 into H, you get 9. Plug 9 into G, you get 85. 85 into F, you get 254. All the way down to this very last step, we had to plug 61,681 into F. And drum roll, please. Final answer, 185,042. If you got that right, give yourself a pat on the back for that one. So in the last half of this lesson, you probably know what's coming here. We're going to stop doing numerical inputs and let's do some compositions that have variable inputs. So this is F circle G of X. Let's see what we find here. What we would have to do is start by inputting this variable X into the function G. Now, I know this seems like a silly step. Basically, we have to take this X away and replace it with X. When we do that, nothing's going to change. Okay, we're still going to be left with 9x plus 4. But now this 9x plus 4 is our output. Now we need to input the 9x plus 4 into F. Or in other words, I'm going to take this x away, and I'm going to replace this x with this new input, 9x plus 4. Now you'll notice once again, if my input is a variable, your calculator is not going to help you out. Okay, you can't type a variable into the calculator. This is something we need to simplify. I'm going to distribute my 3, give me 27x plus 12, and don't forget about the minus 1 over here. Final answer, 27x plus 11. Okay, you can also pronounce this f of g of x is equal to 27x plus 11. Now let's look at a visual of this, okay? Some of you may be wondering, what's the purpose of this? What's the purpose of putting one function inside of another function? Well, a visual, I think it's helpful to look at a visual of this. So, back in our previous example, wrong visual. Back in our previous example, I tried to convince you that a composition of functions is really like having two separate machines lined up but connected kind of through a conveyor belt. Well, when you do a composition, when you find the value of f of g of x, what you're really doing is, instead of having two smaller machines, you're in essence creating one kind of mega machine that can do the job. Okay, and it's called f of g of x. And this one mega machine can do the job of the two smaller machines. Imagine having this large machine 27 f of g of x. And with this large machine, you can simply take a number like 5 and plug it into this large machine, do 27 times 5 plus 11. And let me double check this real quick. 27 times 5 plus 11. It comes out to 146. Look what this large machine was able to do. This composition machine was able to take a number like 5 and in one step kick out this output of 146. In essence, this large machine is able to replace the job that these two smaller machines were able to do in tandem. So rather than having these two small machines work in tandem to come up with the result, Now with compositions, we've created one machine that does the job of both. Now you will find in these examples there is some tricky kind of simplification skills you are going to need. Let's look at our second problem in example 2. Find h, I'm going to read it as find h of f of x. First step's going to be very easy. We need to take this input of x and plug it into f. If I take this x away and replace it with x, nothing's going to change. I have 3x minus 1. I'm going to put a box around that. That's kind of my preliminary answer. What's tricky on this though, now I need to take this output, this 3x minus 1, and input it into h. Or in other words, I need to take this x away and replace it with 3x minus 1. Now look at h for a second. H actually has two x's. This x is being squared and this x is not. Well, guess what? This 3x minus 1, I need to put it in both locations. I need to put it here and I need to put it here. So that's one tricky thing about this example. Now another is the fact that this 3x minus 1 is called a binomial. This binomial is being squared. I don't know how much you remember back from your previous algebra classes, but when you square a binomial, you actually have to FOIL these two expressions together. We have to take, so 3x minus 1 squared means 3x minus 1 times itself. 3x minus 1 times 3x minus 1. And when you multiply two binomials together, it is called the FOIL method. FOIL works like this. Not only do I have to distribute 3x times 3x, which is 9x squared, and 3x minus 1, which is negative 3x, not only do I have to distribute the 3x into this parentheses, I also have to distribute this negative 1. I also have to take negative 1 times 3x, which is negative 3x, and negative 1 times negative 1, which is positive 1. A lot of you probably know this as the FOIL method, is probably how you learned it originally. That's what you're going to have to do. Anytime you have a binomial like this being squared, you do have to FOIL it. Now we can combine the negative 3x minus the 3x, becomes a minus 6x. But when we FOIL this out, we get 9x squared minus 6x plus 1. Now I can carry down the rest of this problem. I'll write it out. Don't forget, we still have this plus 3x minus 1 plus this 3. When I combine all this together in my final step, let's see what I can do here. I can add a negative 6x plus a 3x is going to be a negative 3x. My 9x squared at the beginning, it has nothing to combine with. It's just going to stay a 9x squared. But my negative 6x plus 3x is negative 3x. I'm going to write minus 3x. And then I have a 1 minus a 1 plus a 3. That comes out to positive 3. So final answer, h of f of x is 9x squared minus 3x plus 3. All right, I'm going to kind of leave this example up here so you can reference back to it, but I want you to try this check problem now on your own. We need to find g of h of x plus 5. Go ahead and hit the pause button and work this out on a sheet of paper. As soon as you hit unpause, you'll be able to see the answer, check your work, and see how you did. And here is your solution. I actually ran out of room on my paper, so look over here for the answer. Hey, this was a good problem because right off the bat, you input an x plus 5 into h. If you take x plus 5 and put it here and here, well, guess what? Right off the bat, you're going to be foiling. You have to take this x plus 5 squared, FOIL it, combine it with your x plus 5 plus 3. So when you input x plus 5 into h, we get this, x squared plus 11x plus 33. But now we have to input that value in for g. And here's where I ran out of room, but you can see the distributing and your final answer. All right, so hey, keep the good work coming. Good luck on your assignment, and as always, let me know if you need any help.